We'll create a new project called Physics Dice Roller. Now I will create a 3D scene, call it game, and save it. Now let's add a static body 3D node for our base or platform. I'll call it base. Add a mesh instance 3D to it. And create a new box mesh. I'll set the dimension to 10 meter on the x-axis and 10 meter on the z-axis. I'll leave y at 1 meter. Now let's create a collision shape. Make sure to check simple convex here. Now press 3 vertical dots to add an environment and sun to our scene. Now we'll create a rigid body 3D for our dice. I will name it dice. I'll bring my dice model which I made in Blender. This model is bit messed up, so I will right click it and make local. Then I will drag in the mesh instance and delete the container node. Now I'll just go and reset the scale and the positions. I'll also change the scale to 0.1 to make the dice smaller, like that. Let's add a collision shape to our dice. Let's create a new box shape 3D. I'll change the view to top view to adjust it properly. We'll change the size while holding Alt. Do same for the other side. Now let's switch to the front view and change the size there as well. Add a camera 3D to the scene. Position it as you want, set the rotation as you want. We'll click on preview to see if it's look perfect to us. Let's add a script to dice. Add a roll function which will be called when we want to roll our dice. So we'll reset the global position to the initial position. Don't worry, the initial position is not defined, we'll define it later. Now reset the linear velocity to vector 3.0 because we don't want our dice to move initially. Do same with angular velocity. Now let's apply torque impulse. For our dice size, we'll apply something like 0.15 on each axis. So we'll just use vector 3.1 into 0.15. Now let's define the initial position at the rate on ready var initial position equal to global position. Now we have to define an input which will call this roll function. So just check if input.each action just pressed and pass in UISF. UISF is generally mean enter or space key. So if we either press a space or enter, this method should get called. Let's run the scene and see. Press space, the dice should roll. Yes, it works. Applying same torque impulse may result in same dice face always facing up. We can get away by setting rotation degrees to some random values. We'll initialize it with vector 3 and pass in randy range from 1 to 360 3 times for x, y and z. Now we'll call the randomize function in the ready method. Now let's again run the scene and test it. It works. Add a label node to display value which is facing up and anchor it in the middle. Increase the font size of it. Make it hidden by default. Let's rename it and call it roll value. Come back to dice script and export a reference to a label called roll value. Then we'll drag in the label here just to change it later and assign the reference by dragging in or by selecting from the inspector. We'll hide the rule value label at the start of the rule function. Now we have to make a bay to detect if our dice is still rolling or it has been stopped. So we'll define a variable called isRolling at the top and by default it should be false. and we will set it to true in the roll function. Now we need a way to tell if our dice is actually stopped. In rigid body, there is a property called sleeping, which will be true when our dice is not moving, when the rigid body is not moving, I mean. So if sleeping and is rolling, then we set is rolling back to false. And we'll show the label now, roll value dot show. And we change the text of the roll value dot text equal to you rolled %s and followed by %. Now we need a function to compute the value of the dice. So we'll just place in a function called get roll value. For now, we'll just make a placeholder function get roll value. It should return int at all cases and return 1 from it. Now let's run the game and see. So we rolled and we see 1. But the label is not getting hidden. Why is that? So let's fix that. Let's go back to the code. Let's see what the problem is. Oh, we did not set is rolling back to false. Let's do it now. We will not run our scene just yet because we have to set sleeping back to false because it will not get set to false immediately by the engine. So we have to do it manually here. And see, the label should only appear when the dice is landed properly. Yes, it works. So now let's add a logic to detect which side is facing up. So we'll start by defining the world up position, which should be equal to vec3.up because we want to detect the up direction. I will define another variable called sides, and this should, and in here we have to define all the sides of the dice. And if you made a proper dice, we know that top side is always 1 and bottom side is 6. So we'll type in transform.basis.by :1 for the top side and negative transform.basis.y for the bottom side. And just wait, let me set it for all the direction. Just follow the code. Now let me set a threshold of 0.9, which is used to detect if a correct side is facing up, and max dot is default to -1. We'll also create a variable called value and defaults to -1. So now we'll create a loop and iterate every side and check if the current dot product is greater than the max dot, then we'll set the value according to that side. Then we check if dot product is greater than threshold and dot product is greater than previous max dot. And if it's true, then we set dot max dot equal to current dot product and set the value to sides bracket open side. And at last we returned this value. Make sure to keep the return outside of the for loop, otherwise it will not work as you expect. Let's run the scene and check. So we roll the dice. The value is 3. Yep, correct. The value is 6 now. Correct. The value is 1. Yep. The value is 2. See guys, the code works. So if you liked the video, please share, like, and subscribe the channel for more content like this. Thank you so much for watching.